Hey guys, so today I'm going to be going through differentiation for maths. Part of it today. So first of all, we need to look at what a derived function is, right? So the best way to look at it is if you write a normal function, it's y equals something, or f of x equals something. And the way to write it, once you differentiate each of these, you write it as either dy over dx equals something, or f dash x equals something, or y dash equals something, right? And if you want to differentiate it even further, right, you can continue differentiating the function as many times as you want. So dy over dx, if you want to differentiate that, again, you write it as d2y over dx2. And then, or you can write f double dash x or y double dash. And you can keep on going. You can, if you want to differentiate this, you just increase the number over here. You just say d3y over dx3, and so on, right? And just a quick thing, you don't call this squared. You don't say d squared y or dx squared or d cubed y over dx cubed. You say it as d2y over dx2 or d3y over dx3. And I'm pretty sure if you said something like d squared y, the math teachers will, I think they'll kill you. So better not do that. Yeah, so let's look at this dy over dx. So this d, it just basically stands for difference, right? So this dy is looking at a difference in y, and this dx is looking at a difference in x. And this is basically like a ratio of the difference in y over the difference in x. And what other thing have we seen that's a ratio of y and x? Yeah, it's the gradient. So, because you know how the gradient, you look at the difference in y over the difference in x to find the gradient of a function. And yeah, which basically shows you that if you differentiate a function, you can find the gradient of that function at a certain point. And yeah, so the next thing we need to know is how to differentiate a function. So let's have an example here. So we can have y equals x squared. So dy over dx would be, first of all, you take this 2 and you bring it down, and you keep the x and you take the power, right, the 2, and you subtract 1. So then this would just be 2x to the power of 1, which just equals 2x. So basically, x squared differentiated is 2x, right? And then that, what I said earlier about d2y and dx2, so what you do is take the dy over dx, and you differentiate that, so which will give you d2y over dx2. So we look at this function over here, and you take the power, so 2x is basically just 2x to the power of 1, so you take that power and you multiply it with the 2 times 1, and you take the x and you say 1 minus 1. So then this becomes 2x to the power of 0, which is just 2, because x to the power of 0 is just 1. And yeah, that's how you differentiate x to the power of n. You can just do that. That's the general way to do it. And all right, so the next thing we need to know is trig functions. So let's look at this. So we have y equals sine x. We have y equals cos x. And we have y equals tan x, right? So if you want to differentiate sine x, what you get is cos x. And if you want to differentiate cos x, you have dy over dx equals minus sine x. And if you want to differentiate tan x, your dy over dx would be 1 over cos squared x. And it's really good to memorize all of these. So then if you want to look at more complex situations, it's pretty handy to know that, oh yeah, to differentiate sine x is just cos x, then differentiating cos x is just minus sine x, and stuff like that, you know. And yeah, you just have to memorize them, and after that it'll be good. And the next thing we know is e of x. So let's look at an example here. So let's say we have y equals e to the power of 2x. So what you do is your dy over dx will be, you take this power, right, and you differentiate that power. So then 2x differentiated is just 2, right? And then you take that differentiated thing down there. So you have your 2 here, and then you keep everything else the same. You just keep it the same. Yeah. So then if you just keep on doing this every single time you differentiate it. So we can take our d2y over dx2, which is just differentiating this. So then this will be differentiating 2x would be 2. So then you have your 2 times 2 e to the power of 2x, and then that'll just be 4e to the power of 2x. And yeah, that's just how e functions work. And last one is ln x. So y equals ln of x. So with ln of x, your dy over dx, all you need to know is that if you differentiate ln of x, it just gives you 1 over x. Yeah, as simple as that. And that's it. Alright, so let's look at a function which has more than one of these things combined. So let's say we have y equals sine x plus x cubed or something like that. So then your dy over dx would be, all you need to do is differentiate each of these separately. And first of all, we look at our sine x, and what did we say was sine x differentiated? It's just cos x, right? And then after that, we're done with the sine x part, and we look at the x cubed. So then x cubed differentiated is 3x to the power of 3 minus 1, which is just cos x plus 3x squared. And that's what sine x plus x cubed is differentiated. It's cos x plus 3x squared. And yeah, you can have a lot of combinations of these, and it's just as simple as that. Yeah. Now we look at products of these two different functions. So we already saw that if you're adding or subtracting these different functions, you just differentiate them separately, right? But now we go into the product rule. So let's say we have y equals x sine x, right? How do you differentiate that? Because you have two different functions in there. You have your x and your sine x, right? So there is a formula to it, which is the product rule, where it would be u, so then dy over dx would be u dash v plus uv dash. So then your u would be the first one in the function. Well, your u can be either of them. You can choose which one you want to be your u. So your u can be x or your u can be sine x. And then your v would be the other one. So if I say that my u would be x, then my v should be sine x, right? So the way to do it is, so we said our u equals x and our v equals sine x. So we saw that the dash means that you're differentiating it, right? So then our dy over dx would be, so u dash v would be, we're differentiating the x. So x differentiated is 1. And v, there's no dash next to it, right? So we just keep it the same. So you just say 1 times sine x, and then you add, and your next thing you see is that your u is, you don't differentiate it. There's no dash next to it, so you just keep it the same. So it's just x times, your v has a dash next to it. So you differentiate that. So sine x differentiated is minus cos x, right? And then that's basically it. Now we just simplify it. So 1 times sine x is just sine x, and plus x times negative cos x is just minus x cos x. And yeah, that's how you use the product rule. So you just have to remember that the product rule is dy over dx equals u dash v plus u v dash. And then your u and your v can be anything in the two functions that you have. All right, so that's multiplying. Now what if you're dividing two different functions? So let's say our y equals x over ln x, right? So there is another formula that you need to know, which is the quotient rule. So with the quotient rule, you only use it when you're dividing two functions. So then is again with the u and v. So dy over dx would be your u dash v minus u v dash. Well, okay, let me make the u's and the v's more clear. U dash v minus u v dash over v squared, right? So you can have your u as anything and your v as anything. So let's say our u is oh no, wait, actually your u this time it actually has to be the one on top, okay? Not like this one where your u can be anything and your v can be anything. Over here your u has to be the top one and your v has to be the bottom function. So let's say our u is x and our v is equal to ln x, right? So then our dy over dx is equal to x differentiated. So then the best way to look, the best first step to do is to do x dash and then ln x minus x times ln x dash over our v is ln x, so it's ln x squared, right? So that's that. So x differentiated is 1, so it's ln, it's just 1 times ln x, so it's 1. I mean it's ln x. And then minus ln x differentiated is just 1 over x, right? So it's minus 1 over x times x over ln x squared. So then obviously the x's cancel out here, and you say ln x minus 1 over ln x squared. And that's what you get when you differentiate x over ln x. And yeah, that's all we're going to be doing today in this video. And thank you for listening. I'll see you next time with part 2 of differentiation. Goodbye.